Hi guys, in this tutorial we will program our robot to be able to measure the temperature of the environment, temperature of any substance, maybe liquid, solid, even temperature of human. To achieve this, we will use the temperature sensor DS18B20 interface with the Raspberry Pi microcontroller. There are various types of temperature sensor, but we choose this because it's more efficient, it has high accuracy, and it can withstand harsh weather condition. It can be used in chemical industries, mine plants, and so on and so forth. So for this temperature sensor, it comes in two forms: this, which is water resistance, and this, which is not water resistance. They are the same thing, only that you can use this maybe outside outside the environment, maybe outdoor, maybe during the rainfall or in the water. You can also use it to measure temperature of hot water, but there is a limit. The operating voltage is 3 to 5 volts. It can only measure between minus 55 degrees Celsius to 125 degrees. That is, you can use it to measure temperature of a boiling water. It has accuracy of plus or minus 0.5, and the resolution is 9 bits to 12 bits. Okay, now this sensor has 3 pins. As you can see, it has 3 pins: the VCC, the ground, and the data. So as we all know, the VCC and the ground pin are used for the power, while the data pin is used for the communication. And this sensor is a one wire communication device. So to use this sensor, the first thing to do is we will interface it with the Raspberry Pi controller. But to interface it, you must pull this data pin high. It must be high. You must pull it high. That is, you must interface a pull-up resistor with the VCC. Okay, so this is the connection. To connect it with the Raspberry Pi, so the VCC pin will be connected to the 5 volts or 3.3 volts, the ground pin to ground, while the data pin to GPIO 4. So between the data pin and the VCC, so you have a pull-up resistor. So let's take a look at the hardware. So these are the two temperature sensors. If you take a look at this sensor, this is the onboard DS18B20. It is onboard. You do not need to get a pull-up resistor to pull up the data pin. The resistor is already embedded on this board, so it is not necessary to have a pull-up resistor. So if you get an onboard temperature sensor, you do not need to connect an extra resistor to pull it up. But if you are using this, of course, you need another resistor, maybe 10k or 1k or 4.7k, to pull up the data pin. So this is the VCC, the ground, and the data pin. Okay, so for the connection, we'll be using both. So for this, can you see this S is for the data? Okay, so this pin is data pin where you have S, while the one for minus is for the ground. You can see, so the ground is connected to the ground terminal of the Raspberry Pi Zero. Okay, so while the VCC is connected to 5 volts, then data to pin 4, GPIO 4. Okay, so for this sensor as well, I've added the pull-up resistor. So now that we've interfaced the temperature sensor to the Raspberry Pi, now we'll power it and connect it wirelessly so that we can see the desktop environment in the VNC viewer. So this is the VNC viewer. So the first thing to do is to enable the one wire communication interface. So to do that, you can use the terminal Raspberry Pi configuration sudo raspi config. or you come down here to click on this, then you come and click on preference Raspberry Pi configuration. So when you click on that, so you're waiting for some seconds for it to load. So you click on interface, one wire. Can you see it is already enabled here? If it was not enabled, you click on this to enable it, then you click on OK. Then when you click on OK, it will ask you if you want to reboot, because you must reboot it. You must reboot it so that it will be enabled. If you don't reboot it, then it will not be enabled until it is rebooted. So you enable it and click on OK, then it boots itself. Now the next thing is to verify that the one wire kernel module have been loaded after it has rebooted itself, because the reason why we need to reboot it is for the one wire kernel module to be loaded on the next boot. So to do that, we need to type in this command nsmode this symbol grep. So we need to type that into your terminal. Can you see? Then type on enter. So can you see W1, that is one wire terminal, and then the GPIO that was connected to. So if you can see this, that means it has been loaded on the next boot. So you can close this, then click on this programming turning to write your Python code to read the temperature. So after you've loaded the tuning, then you type in your code. So I've typed in my code, so I will explain this code to read the temperature value from the sensor, from DS18B20 sensor. I try to comment it out. So I have import globe. So this is for the global function, is the global module. So this function is used to search for files that match a specific pattern. So import the time library, then you change it directly to the W1 directly, the W1 device directly. W1 means the one wire device communication. So this will return all the list of directories, and you switch it directly where the device folder is. Then with this you can read the raw temperature, the raw value. The raw value will be in form of hexadecimal file. It won't be in form of degrees Celsius or the Fahrenheit. So after that, so from that raw value, you need to convert that temperature to degrees Celsius and Fahrenheit. While true means you look forever. And then you print your temperature, then you wait for 1 second. So it repeats this every second. Okay, so when you are done, then you can run. Or before you run, let's stop. Before we run, let's save our Python file. So you click on save. So when you click on save, give it some seconds. So let's save it as DS18B20.py. Okay, you scroll down, click on OK. So after it has been saved, you can go back there and run. So it's now running. So this is the temperature in degrees Celsius and Fahrenheit. So I've also interfaced the water resistance temperature sensor. So still within the ambient temperature. So if I try to hold it, it should read the temperature of my hand. Okay, it increases gradually to a stable temperature. The temperature is not stable. Okay, thank you for watching.